Welcome to the video on characteristics of waves. This will be very brief. I sure hope that all of the things that I'm going to say are review, but I just want to make sure you do know them. Waves, light, we're talking about light this unit in addition to electrons. Light travels in waves, sound travels in waves also, but we're going to be discussing light waves. And waves have two properties, basically. They have two components. So the distance from a crest to a crest, or the distance from a trough to a trough, is called a wavelength. Wavelength has an abbreviation that comes from the Greek alphabet, and that is the letter lambda. It looks like that. Okay, so if you ever see that, that means wavelength. The other property of waves is the amplitude. Amplitude is the distance from the middle of the wave to the top of the wave, or from the middle of the wave to the bottom of the wave. Doesn't matter. If it's the middle, it's still the same. Some people are under the impression that amplitude is the height of the wave from top to bottom, and they get that wrong on the standardized test. So just remember, it's from the middle to the top or the middle to the bottom. Doesn't matter. Another term you need to know about waves is frequency. Frequency is the number of wave cycles that pass through a fixed point in a second. So cycles per second. So if I had my hand here and this wave was traveling like this, how many wavelengths are going to get through my hand in 1 second? That's your frequency. You can have waves with two different frequencies. So if you see this wave here, it's going to have a lot more wavelengths because its wavelengths are shorter. Since its wavelengths are shorter, more of them will get through my hand in the second than for a big wave like this. Frequency has a unit of hertz. Hertz is also inverse seconds, which is sometimes written seconds to the -1. It's the same thing as inverse second. Wavelength is in some sort of distance unit. You can do it in meters. We typically do it in centimeters. You can sometimes see it in nanometers. We don't really talk about amplitude that much as far as what we're going to be doing in our class. So we have wavelength, we have frequency. The last thing is energy. The higher the energy, the higher the frequency. So energy goes up, frequency goes up, and as you may have noticed, your frequency increases if your wavelength decreases. So wavelength goes down. So energy and frequency are directly related, and energy and wavelength are inversely related. And you need to know those relationships for the test. In class, we're going to be doing actual calculations with formulas to calculate how much energy, how much frequency, and what's the distance of the wavelength in different ways. But for right now, you just need to know the relationship between those three things. Thank you.